Hello and welcome back. Alright, today we are going to take our first look into object-oriented programming. Now if you go and try to find a definition of object-oriented programming, you're going to find a ton. Part of the reason is that it's not really that well defined across implementations of different programming languages. So C++ adds additional features that a language like C# doesn't have, and so the definition starts to get kind of ambiguous the deeper you go into the topic. But at a high level, object-oriented programming is the same throughout all languages. And the basics behind object-oriented programming is that we push our objects to the forefront in our program. So let's go ahead and let's kind of look at what our typical program has looked like up to this point. And we'll use our linked list example that we did in the last couple videos. So in those videos, we basically had our list over here, and then we had our functions that manipulated that list. Now there was a loose dependency between these two. Our functions took in a list pointer, and we couldn't really do much with our list without the functions unless we wanted to do everything manually. But these functions in the list were separate and disjoint. Well, the heart of object-oriented programming is to bring these two ideas together, so that instead of having these disjoint relationship between a list and the functions that can manipulate the list, why don't we just have one simple thing called a list, and it has two sections: our data and our functions. And this right here is what object-oriented programming is all about. So object-oriented programming is also called OO, or sometimes you'll see OOP. Alright, so this grouping of the data and the functions, well, this is what is known as a class. And so a class defines both the data and the functions that we use to manipulate the data of that object. Now, the class is what is referred to as the layout of the type, layout of the data and the functions. So when we defined what the struct of our list look like, the data members, well, I guess the pointer just to the head node, that's the class. When we talk about specific instances or specific variables of lists, we call those objects. So objects are instantiations of a class. So you can think of a class as like a blueprint, which defines the layout of the data that is representing. Okay, so now that we understand what this class is and what objects are, when we talk about the individual components of a class, we refer to these as members. I'll just write it down here. Members. And then there's two different types. There are member fields. This is your data. And member functions. And these are your functions. We'll also call it behaviors. There's another word that we use when we talk about functions that are part of objects, and that's methods. Now, some people use methods and functions interchangeably, so don't get too confused or too, I guess, uptight about holding to those definitions, but methods is, in my opinion, the more technically correct way to call a function of an object. But you'll hear them as called member functions, member fields, or just methods. So you always know that a method is supposed to associate with a specific class. And so that's kind of the breakdown of the class layout. Yeah, it doesn't too exciting. For some reason, this gets somewhat complicated, and the complication comes into play when we start talking about each language's implementation. The syntax for classes end up being pretty similar to the syntax of a struct. So let's go ahead and take a look at the syntax. So we had a struct, and then you had the name, so let's call it list, and this was simply a list pointer to head, and curly brace semicolon. Well, we define a class exactly the same way. But instead of using the struct keyword, we use class. And we could do list and there we go. We've defined our first class. Now the interesting thing to note is that these are nearly identical. In C++, the struct keyword is synonymous to the class keyword with one caveat. When we define these blueprints for classes, we can have these things called access levels, also called protection levels. And what these do is these provide a way to limit your code visibility to the compiler during compile time to different, basically to limit the visibility. And so the reason why you'd want to do that is you may actually want to hide implementation details. And so the three basic ones that we're going to talk about are public, private, and protected. So when something is public, that means everyone has access to it. When something is private, that means only your member functions have access. And protected, I just wanted to throw protected up here because you'll see this a lot when you're looking at code. But this has to do with the visibility for inheritance, which we will be talking about later. So don't worry too much about this. I just wanted to show you that way if you see it, you know, hey, what's that? Well, it's one of the access levels that we can use to hide our code. Okay, so how do you actually scope these in your class? Well, what you do is you simply do class, list, and then you type in one of these words. So let's say public. And now public and then a colon. And so now all of the code that you write within this area is going to be public. If you want a private section, you simply write private and a colon, and then all of this. And if you wanted to, you could even make another public section. And so all of the definitions for your members in each one of these blocks will be under the access protection level of the scope that it's under. So if this says public, everything down either until the end of your class definition or until the start of a new protection level will be of this type, or will have this level of access in your compiler. So what this means is that when we actually define our list, so by default, a class, everything is put into the private scope. So this is the default. The difference between a struct and a class, and this is really the only difference in C++, the difference between a struct and a class is that for a struct, the default is public. Public is default. So a class is private. So really, a struct list star head is the same thing as class list public list star head. Those two definitions are exactly the same in C++. So we cheated a little bit when I was talking about that in the first video with the struct. If you were talking about C, this would actually be different. You're not allowed to associate functions in C, but you can do this in C++. And so we define functions the exact same way inside this class definition. But when you go to implement them, you actually have to do something a little bit different. And we'll talk about it in the next video when we actually convert our list into OO style programming. So with that, I think that's good for this video. And in the next video, we will actually take that list program that we made and turn it into OO. All right, thanks.